Hello there! Are you looking for a fun way to introduce the concept of energy? Well, we have an inspiring idea to share. It is a science toy to help your students better understand the topic in a more engaging way. This is what it looks like from the main angles. This is how the toy car looks like from the front. And this is how it looks like from the back view. The car looks like this from the left view. And finally, this is what the car looks like from the right view. To build this toy car, you will need ice cream sticks, clips, cable ties, razors, metal skewers, 4 wheels, large rubber bands, a hot glue gun, and a cardboard with car template on it. This is how we made the toy car. So, this is how you operate the toy car. First, you secure the rubber band to the knob of the car. After it's secured, pull the car back to rotate and wind up the rubber band. When you release, you should see the car move a certain distance. This toy could help your students reach the following learning outcomes: to identify forms of energy, which are elastic potential energy and kinetic energy, to explain the process of energy conversion from elastic potential to kinetic energy, and to apply the concept of Newton's third law. This toy is suitable for students of grades 4 to 6. The first educational concept would be 2 types of energy, which are elastic potential energy and kinetic energy. Elastic potential energy is potential energy stored as a result of deformation of an elastic object, such as the stretching of a rubber band. On the other hand, kinetic energy is the energy of motion, which is energy released by any moving object. The second educational concept is conservation of energy. You may explain to your students the law of conservation of energy. It says that the total energy of an isolated system remains constant and conserved over time. It is not created nor destroyed. Rather, it can only be transformed or transferred from one form to another. The toy car moves because of the exact same law. Initially, the rubber band possesses elastic potential energy when wound up. When the car is released, the elastic potential energy changes to kinetic energy, making the car move. The third educational concept is Newton's third law of motion. While you teach with this toy, you can also mention that we are able to observe Newton's third law, which states that for every action there is an equal and opposite reaction. In this case, we rotate the wheel towards us, and when we release, the car moves in the opposite direction. This is a suggested hands-on activity for you and your class. First, you could gather the students to the front of the class to have a closer look at the toy. Then, distribute a worksheet to each student. Assign one student to rotate the rubber band 3 times and release it. Another student can mark the distance traveled by the car. To see how far the car travels in relation to the number of rubber band rotations, you can next rotate the wheels 5 times and mark the new distance traveled. While doing the activity, you can guide your students along a worksheet to help them organize their observations and predictions. We put our example of the handout down in the description below for your reference. You could make it a bit of a challenge for your students. For an extended activity, we suggest asking students to build their own toy car over the weekend. Let them manipulate certain variables: weight, number of rubber bands, anything they can think of. They might like to race their cars and see whose car travels the furthest and the fastest. That's all for now. This project was done by Lee Sin Ying, Tan Mei Mei, Ilya Nadra, and Ku Ying Shan. Thank you.